Okay, y'all, so we're going to be going over 4B, dealing with interest. I'm going to do a few questions from the report just to get y'all used to decimals and fractions, okay? So this will actually be 4B's report. And I'm just going to do a few questions on this, okay? So first of all, I'm going to turn decimal into percent. You know, the trick on this, turn a decimal into a percent. You move the decimal right 2 places and then add the percent sign. So move the decimal right 2 places and add the percent. So I'll do a few examples on that. So we're going to find percent notation. So I'll do one, how about 0.25?
$25%.
Yeah, because all you do is move that decimal twice to the right, and then add your percent. Now, that was perfect on 9. And just remember, anytime that decimal is after the last number, we don't really need to put it there. Okay? Now, if I was looking for more accuracy, I could keep the decimal and start adding zeros, but they didn't say how accurate it would be. So if that came out to 25 perfectly, drop that decimal and pick up. So let me see what y'all would do with this. What if I had 0.9?
That'd be 9%.
Take the 2 zeros behind the 9, so that will equal 900.
Oh, remember, yeah. I moved it 1.
Right.
9%.
And then 2. So that
I need it. And then that'd be what? 9.
Okay. So you're only taking it over 1 decimal point instead of the 2 when it's a single digit.
But notice I did do my 2 places. My decimal was in front of a 9. When I moved it behind the 9, that comes with 1 move right there. And then I had to add the 0 to get the second move.
Okay, I see now.
Since this one had a decimal for the right foot of that very first number. All right, next we'll look at to turn a percent into a decimal. What's the direct opposite of it, right? Instead of moving my decimal to the right twice, we're going to move that decimal to the left. So move left 2 places and remove the percent. And I'll tell you basically what's happening. When we move that decimal right 2 places, we're basically multiplying by 100, because that's what's moving it. Then when we move left 2 places, it's like we're dividing by it. Okay? So on these examples, we're going to find decimal notation. So how about 79%?
That'd be.
Now, what you gotta remember, since there's not a decimal here, you gotta keep that decimal like it's after that last number. And then I think I heard it online,
0.79.
because you took this thing for that once, that twice. And there we go, 0.79. Okay. You don't do that, are we? What about if I did 42.8%?
That would be 0.43.
Let's see.
428.
Oh, yeah, they're keeping all the digits. So I'm just
Point
gonna
two.
have to-
428.
That's what I'll do.
428. Okay. 28. That's not yours.
All right, one more of these percent, I will do 7%.
That'd be 0.07.
Yeah. So they moved it twice and they had to add a zero to that to get me a 0.07. So good job on that. So let's see how y'all do with this. I'm bringing up y'all favorite type of numbers. So on this one, we're going to find decimal notation. And percent notation. And they're giving me 4/5. So the first thing, to turn a fraction, I would turn that fraction into a decimal first, and then I would start playing with the decimal and the percent notation. So how are we going to turn that fraction into a decimal? Well, we're going to take that 4 and divide by that
5.
You know, if you do that on a calculator, 4 divided by 5, you should get
0.8.
a 0.8. There you go. So there's my decimal notation right off the bat. So this is decimal notation. Now I need to take that decimal notation of a 0.8 and y'all turn that into a percent for me.
80%.
Bam, that's it. So once again, they had to add me a zero here, right? So that would give me 80%. Okay. You know, those aren't too bad anymore. All right, so questions online? Y'all good?
Mm-hmm.
All right, so let's get into the actual gist of the MR assignment today. So 4B for MR deals with formulas and examples. Yeah, this will be some of the homework problems. What I'm going to do is give you my formulas first, and then I'm going to do some of the problems you'll see in homework. Some of them are sort of tricky. So the first few were just like answer questions, but when you started getting into the actual math, you want to need these formulas I'm about to give you. So the first formula I'm going to give you is for the simple interest. Simple interest is when they only charge you interest one time a year, like on a yearly basis, okay? So this is for simple interest. Y'all, the formula for simple interest is A equals P times parentheses 1 plus APR times Y. So let me tell you what everything is here. The P is your principal or your starting amount. So this is called the principal. Let me make sure that it's or starting amount. Well, 1 is 1. APR, guess what? That's your annual percentage rate. That's the annual percentage rate. Now, think about this. Annual percentage rate, they're going to give you as a percent. In order to work it in that formula, you got to take it out of that percent and put it into decimal form, okay? So we cannot multiply by percent, we need those in decimal form. Guess what Y stands for? Years. How many years is this loan going to have? And then A would be my final amount. So it would tell me how much I got to pay once I took my principal and applied this interest rate to it, okay? So if I bought something for $10,000 and I'm paying $5,000 a year interest, well, each year, whatever 5% of that $10,000 is going to get added on to that. But it's going to happen just once a year, okay? Then we got compound interest. Compound interest is what people like credit cards do to you. Every month you get a bill, they've added interest on it every month. So they might do it monthly if you're paying payments monthly. Some places might do it bi-yearly, twice a year, which would that be semi-annual. So just depending on what type of loan you get. In banks, they'll do this kind of stuff. The compound interest takes the amount of your balance every month, figures out the interest on it, and adds it to it. Then once you pay a payment, the next month you got a new balance, it takes the interest on that, adds it to it. So it's doing this every month, 5% a month or 2% a month, whatever they got. Okay? So the formula for compound interest would be A. Now they're really similar if you get to the stuff I got in parentheses here. But this equals P, which is still my principal or my starting amount, times 1 plus APR divided by N, and then that's raised to the exponent N times Y. So A is still the final amount, P is still the principal or the starting amount. APR is still annual percentage rate, but I've got an N on here now. The N stands for how many times it got compounded a year. So this is the number of compounds per year. Now, y'all, the big ones we like to do, we're not going to do annual because if it was an annual compounding, it would be a simple interest. But that happens just once a year, okay? compounded interest, you might see stuff like semi-annually, which would be 2 times. You might see quarterly, which would be what, 4 times? I ain't seeing nothing in the homework really dealing with like weekly and daily and stuff. Most of them they stick on semi-annual and quarterly. And then you put the same thing here, that's still the number of compounds that in, and then Y is still the number of years. But what happens, if this only got compounded once a year, well, APR divided by 1 would be the APR, and then that would be 1 times whatever the years are, okay? All right, so a couple more formulas, and then I'm going to start going through these homework problems, okay? All right, this formula finds principal. So the formula I'm about to find for the principal, an example of that would be, suppose in 5 years I wanted $50,000 to put down on the house. And I knew the bank would give me a certain interest rate. Well, if I wanted to end up with $50,000 to put on my house, this formula tells me how much I need to start with. So that when they add the interest in my 5 years, I got my $50,000, okay? So it's sort of like what I gave you here, but it's rearranged a little bit. Because instead of solving for the A now, we're solving it for the P. We wanted to know the starting amount that would get me that final amount, okay? So this was the trickier one, but it's the final, the principal that you need to start with. We take the A, which is the amount, and we divide by all the stuff that's in the parentheses. So we divide by 1 plus APR divided by N, all raised to the N times 1. So to find my starting principal I need, I take the amount I want and divide by 1 plus the annual percentage rate divided by the number of compounds they're going to give me per year. Now, this stuff in the parentheses is all affected by this exponent, which is the N times Y, which is the number of years times the number of compounds. And I'll show you how to do this on the calculator. You got to be careful because you take this and it's got to divide by all of this. Okay. So a lot of times, I'll show you, I might use parentheses more than what they got. All right, let's look at one more for the annual percentage yield. Which could be also called effective yield or just yield, is the actual percentage by which a balance increases in a year. So the actual percentage by which a balance increases in 1 year. Right, so to find this annual percentage yield, you're going to take so the APY, which is the annual percentage yield, is calculated by taking the absolute increase they take the absolute increase, which would be basically you got a starting amount and an ending amount. The increase is how much it went up. And we're going to divide that by the where'd it go? By principal. So we've got our formula, right? So now let's knock out some of these questions. Now we'll say this. Usually when you get hit with banks hitting you with compound interest versus simple interest, compound interest, you're usually going to pay a little bit more than you would if you had simple interest. Because they're hitting that income, if it's quarterly, they're hitting it every 3 months with interest versus once a year on it, okay? So y'all answer this question here. Bank A was offering simple interest at 3.5% per year, which was clearly better deal than the 3.5% compound interest rate at Bank B. Does that make sense or not? Well, what I said on that was it did not make sense because the compound interest pays more than the simple interest. So your number one should be sort of like that, London. Pick over the one here. You don't got it, but it could be. Yeah, see, same thing here. So let's get into some of the math then.
Yeah.
So y'all, here we go. We're going to calculate the money we'll have at the end of the period. So calculate the amount of money at the end of the indicated time period. So we invest $4,000. So $4,000 is invested in an account that pays simple interest. So simple interest of 7% for 20 years. So since we're dealing with simple interest, we know we want to use the first formula I gave you, which said A equals P times 1 plus APR times the number of years, okay? So we know P, they gave me the P, which was my starting amount, which was $4,000, right? Well, the formula has next one of 1 plus APR. Now my APR is 7%. But I cannot put 7% into my formula. You're going to have to turn that into a decimal. Now let me stop sharing and go back real quick. I'm dead on here. All right, looks like I'm unfroze now. Hey, y'all, if I freeze up, just let me know on there, all right?
Yes.
All right, so you're going to turn this 7%. That's why I'm showing y'all the report stuff into a decimal. So you're gonna take the decimal and move it last 2 units. So that gives me a 0.07. I'm going to now put that into my formula here. 0.07 times my number of years, and they gave me that, right? They said this would happen for 20 years.
You said 40 years?
20.
Okay.
So to work this, order of operations is what's going to happen. You're going to work inside the parentheses first, and you're going to multiply before you add. So what we want to do now is figure out what is 0.07 times 20. I'm just going to bring everything down. So multiply first before you can add. So y'all 0.07 times 20 gives me 1.4. Now, I'm still inside the parentheses with stuff I can do. So I'm going to bring down my 4,000 and multiply by what I get when I add those parentheses inside. So I got 1 plus 1.4 will give me what? 2.4. Now, y'all got them nice calculators? TI-83, TI-84. You can punch this thing in like it books.
Yeah, I got one.
So now y'all finish out. Let me take my 4,000 times my 2.4. And what you get? 9,600. So that means if I invested $4,000 at simple interest of 7%, in 20 years, I more than doubled that money. I started with 4,000. I made about 5,600. Now the difference is if that would have been compound interest, I'm getting my interest compounded more than once a year, I'm going to make more money. Okay. All right, questions on that?
So that's the final answer.
Yeah, final answer would be my $9,600. So let's go to some of that compounded interest. A little bit more work, but it's trickier because you got that exponent sitting in there. All right. So this example. I'm going to use the compound interest formula to determine the accumulated balance after the stated period. So compound interest. I got $6,000 invested at an annual percentage rate of 6% for 3 years. Compounded annually. So they want to know what is the amount of money I'll have after 3 years. Now I'm going to tell y'all the truth on this one. Anytime I'm compounded annually, which is once a year, is basically going to be the same as simple interest given on this. Okay. So let's bring out the compound interest formula, which is A equals T times 1 plus my APR divided by N, all raised to the N times Y exponent. So y'all, here's what I'm going to do to figure this one out. I'm going to start by dividing that APR by N. Once I get that, I'll add that to the 1. Once I've done everything in the parentheses, I'll raise that to whatever this n times y exponent is. And then my final step, I'll multiply by the p. So the p is going to be your final step if you're doing this by hand. Right? So what is p? I don't know why I'm freezing, y'all, but let me try to fix that. I don't know if it's freezing on y'all end, but it keeps freezing on my end, it looks like. All right, P was my starting amount, so that is
$6,000.
$6,000. All right, 1 plus. So what am I going to put in here for my APR?
6%.
But what y'all going to do to that 6%?
Oh,
You're gonna take it to the left 2 times behind that decimal. Okay.
Yeah. So you all need to make that with a 0.06 for me, all right? N is the number of times it got compounded per year. Well, if this is compounded annually, it's just 1 time. There you go. And then here, N again is still going to be 1 times my Y. How many years was it? And there we go. So, working this by hand. Now, I'm not going to lie, calculator knock this out really quick and punch it in like it does. Now, 0.06 divided by 1 is going to be 0.06, right? So that 0.06 added to 1 will be 1.06. Then my exponent, 1 times 3, I can just make that 3. So see what's happening in this formula. You're taking your balances that you have, and this 1.06 is what the interest is doing to that balance. How much is increasing it by? So y'all, what happens when you multiply by 6,000 times? Now, let me show you what you got to do first. Take that 6,000. Figure out what is 1.06 to the 3rd power. So that'll be 1.06. You can multiply capital 3 times or use your exponents on your calculator. But you should get, I'm getting around to 1.191 on that.
Yeah.
Now, final step, you take this and now multiply by 6,000. So take what answer we just got, multiply by 6,000. And y'all, they want me to round to the nearest tenths, so that's 2 decimal places. So I'm getting something like a 7146. 0.096, so I'm going to round that to 0.10, right?
So we got. Oh, I did. I left the zero out of it. I did like that. I left that 1. 6 down.
Let me see. Oh, I see what you're saying. Oh, I just did. So what I did on mine, I keep my accuracy. So once you did the 1.06 to the 3rd and got that answer, take that down and multiply by 6,000.
Oh.
Then it won't lose no decimal places for you. Then when you get entered, then you can round that 0.096 to a 1 up. Yeah, I usually try to keep as much accuracy like as I can going through.
I'm confused. I got a flat 7146. Where
You
did
got
that
what?
come from?
What was that question, Ray?
I got a flat 7146. Where'd you get the 0.10?
Oh, how many decimal places are you leaving when you do that?
None.
When-
I got a flat 7146,000 times 1.
So here's where you are losing accuracy. When I did the 1.06 to the third power,
Mhm.
I took that answer and multiplied it by the 6,000. I didn't start over and round it or anything. Because what's happening is if you don't leave enough digits, it's not going to round out enough for us. So when you do the 1.06 to the third power, leave all the decimal places and take that answer and multiply by the 6,000.
Okay.
And then that's what usual was doing. If you round off to the 1.191, it's not going to give you enough digits, enough places out, okay?
Okay.
So when I actually did the 1.06 to the third power, I actually was using 1.191016. So I had a lot more decimal places and I multiplied that by the 6,000. Okay.
Okay. Gotcha.
So basically, if I do this by hand, I don't drop them off. I mean, I rounded it here, but on paper, I've got all these decimal places going. Okay? All right, same formula. But this time we're going to invest $16,000 for 9 years. Annual percentage rate of 3%. And we are compounded quarterly. So once again, we're on compound, so I'm going to use the same formula we just used. Which we got what? A equals P times 1 plus the APR divided by N, all times the N times Y for my exponent. All right, y'all, let's see. We know P is
16,000.
Okay, 16, right?
Mhm.
All right, then we got 1 plus. So I know the APR is 3%, but what am I putting into my formula? Because remember, 3% is turned into a decimal.
03.
So you're going to get a 3.03. That's good. N is the number of compounds. Oh, well, they said it was quarterly, right?
But I mean,
Which would be 4 times a year. Okay, so when they say quarterly, it's 4 times a year. Semi-annual would be 2 a year. So this would be, N is going to be 4 for us. So those parentheses, and then you got 4 times the number of years. So where did I put that in? I had 9 years, so Y will be 9.
okay, you said quarterly is 4 years.
Mm-hmm.
And what is 1 year?
Semi-annually would be twice. Annually would be once a year. Daily would be 365 times a year if they did daily. Weekly would be like 52, but you really don't see a lot of weekly and daily stuff going on. That'd be a lot of interest. All right, y'all. So what I'm going to do, bring down to 16,000. I'm going to figure out what. So this is going to be 1 plus 0.03 divided by 4 is giving me 0.0075. And then I can figure out this exponent because 4 times 9 is 36. So notice I'm sort of doing two things at once. I was doing this division because it was inside the parentheses, but then I was also multiplying that exponent real quick. So now bring down to 16,000. Add the 1 plus the 0.0075, that'll be 1.0075 raised to the 36 exponent. So now that I've done everything inside the parentheses, I need to take that 1.0075 and raise it to an exponent of 36. So if you did that right, you should get what, a 1.3086 45371. That's all the digits it's showing me on the calculator. But I write as many of them digits as I can, y'all. And basically, I say that answer I just got on the calculator and then multiply that by the 16,000. When we multiply the 1.3086 times 16,000, in this one, we're going to round to the nearest cents, so 2 decimal places. So y'all, what are we getting? A 20,938. 2 decimal places. This looks like it's around to a 0.33.
Okay, so when I put in 16,000, you said times or divide? So what would I got? Did I do that wrong? 16,000 times 1.007.
No, you're not. What's wrong with it? I got 20,938.33, but you got to round this to the nearest cents.
Oh,
See when they see the answer, it'll say round to the nearest cents. So what you would do, the round it, so there's your 3. The 2 would be where your cents is at, right? So since the 2 has a 5 behind it, round that 2 to a 3. You'll get what I got. Okay. I've noticed most of these want to round off 2 decimal places, which is the nearest cents on them. And we'll be at 3.325. So since I had a number of 5 or greater that was after my 2, I had to round that up to a 3.
hold on, no. I think we're doing the wrong thing. See, this right here, you see what you got right here? The 16,000.
Oh, yeah.
What did I do?
No, you're right. You just did it all in one step. The 1.0075 part of that to the 36 power would give you all that.
Oh, okay.
You're
Okay. I did it all
right.
together.
And then when you
Okay.
multiply by the other 16,000,
Okay, I thought it was like,
you're
Okay.
but that's what I'm saying. The calculator can do it all at once.
okay.
To where I was sort of breaking mine into steps to show y'all like.
So it was still right. I did.
Yeah.
Okay.
So if I was doing it by hand, but you did all this at once, where I did this part and then did that. So
Okay.
your calculator said, hey, I can do all that at one time. So let's get it all out. Okay, so yeah, I'm gonna at least be able to cover some of these problems I got here now. I'm gonna find the annual percentage yield and it said the bank offers APR of 5.6% compounded daily.
Oh, so we're gonna do,
It is only on this one though.
okay.
So on this one, since they don't give us a amount they're investing or anything, we're just going to know what's going to happen. What will our money yield per year? We can choose any amount that we want to start with. So y'all, I'm just going to choose to use $1,000. Okay, if you want 10,000, I usually get stuff that's got a lot of zeros after it, so I don't have to play with decimals a lot. But any amount you can start with. So for the percentage yield, I'm going to use $1,000. So now we got to find the interest that this $1,000 will make in a year. So first, find. Oh, hell, let me write that again. So first, find the interest. And the interest, we got a formula. A equals P times 1 plus APR divided by N. And then the exponent is N times 1. So you started out by using that interest formula. We got to find out what money is going to be there after that interest is applied to it, okay? So I chose to start with $1,000, so my P will be 1,000. And then it's 1 plus. So y'all, my APR, 5.6%. Put that in a decimal. So what's that? 0.056. N is the number of compounds per year.
That's gonna be.
Well, this thing is daily compounding. So how many days are in a year?
365.
365. You right there. So divide that by 365. And then your exponent is going to be 365 times the number of years we said. Which is going to be 1, ain't it?
Yeah.
Because we're just looking at this for 1 year of interest, okay? So remember, you can pick any amount you want for your P. All right, so I'm going to plug this in and see what my calculator gives me for this. So I got 1,000 parentheses 1 plus 0.056 divided by 365. Close parentheses and then raise it to the exponent. Well, 365 times 1 is just going to be 365. If you did that right, you should have 1,057. I'm going to go 2 decimal places. Looks like a 0.59. So this is how much money I'll have after 1 year of this compounding, right? So now that I know that, I can find the differences I need. So let me get some more room here. So I gave you a formula a while ago that said the annual percentage yield equaled the absolute increase divided by the starting principal. To find the absolute increase, you take this amount, 1,000, 57.59. You subtract what you started with, or what I start with. 1,000. Once we get that answer, we're going to divide that by the starting amount, which was that 1,000. All right, well, we know 1,057.59 minus 1,000 will leave me 57.59 divided by 1,000. All right, let's figure out what that equals. 57.959 divided by 1,000 is going to give me
0.0575.
okay, but guess what? Y'all going to have to turn this into a percent. And let me see how many places. We're going to round it 2 decimal places after the decimal, okay? Which means I'm going to take my decimal. First of all, I got to move it to the right, don't I?
We'll be behind the 5.
So we're behind the 5 now. All right, y'all. So 2 decimal places means where that 5 is. That 5 will now turn into what?
We'll turn 6.
This will be 5,
6.
7,
6.
30.
Okay.
Since my 5 had a 9 behind it, that rounded up to a 6. So that's not bad. But first, remember, when you're looking for the annual percentage yield, you got to find how much money you made on that $1,000 that first year. And then put it into the formula we just used. The absolute difference is the ending amount minus the beginning amount. And you divided all that by the beginning amount. Okay? And this is how much of, well, 5.76% of your starting $1,000 is what you're yielding a year. Okay?
So let's say yield, then we have to do that one too.
Mm-hmm. For the annual percentage yield. And there's going to be 2 of those, and they're both really similar. The only difference is they're compounded different. One's daily, and the other one was monthly. It would be 12, right?
Yeah.
Okay. All right, y'all. So I wanted to at least finish these next ones. We probably won't do a lab today. I was going to do a lab today, but I sent y'all the stuff. I think I'm just going to. We're having issues up here in our labs, internet and stuff. So I might extend that due date just a little bit. If they get my labs all going next week, we'll be able to get in here. But I'm not able to pull my stuff up on it, so I'll try to get that figured out. All right, let's do a good one. These might be something. Remember I tell you, so y'all, the next formula we're going to look at. Suppose you got kids. So suppose in 10 years you had a kid going to college. And before your kid went into college, you wanted to save, say, $75,000. Because you knew if you could save $75,000, that would make it a lot easier on the kid. Might not have to take out loans and all that stuff. So we're going to look at a formula that would tell you how much you need to invest today at a certain interest rate in order to have $75,000. Okay. There might be different numbers than that, but y'all get the gist of it. Like you want to save money for 5 years, and you got a bank account, you're putting it in and drawing interest. These formulas tell you what you start with. All right, y'all, so here we go. How much must be deposited today into the following account in order to have $50,000 in 5 years? So I want $50,000 in 5 years. and it's gonna be a down payment on the house or something. You got an account with annual compounding. And APR of 5%. So we're going to find out how much money we need to start with in the very beginning for this account to have $50,000 in 5 years, okay? At an interest rate of 5%. So the formula you'll use for these, since you're looking for the starting amount, you're looking for the P on this one. That's going to equal your A divided by 1 plus APR divided by N, all raised to the N times Y. Now, we'll say when I do these on the calculators, I put extra parentheses around those on the calculator. If you don't put extra parentheses, it'll divide before it does the exponent. And we wanted to take that top and divide by this complete bottom. So anytime you got more than one thing on top or bottom, put extra parentheses on. So what's A? What's the amount I want? I want 50,000. So A is going to be 50,000. Then we're going to divide that by 1 plus my APR, 5%. We all 5% needs to be turned into a decimal. 0.05. Divided by N. This is annual compounding. So N is 1. And then 1 times the years. And the years I said was 5. So y'all in the calculator, you gotta put these extra parentheses on this. Knock this out, okay? So I'm gonna start out by doing the bottom. This would become 1 plus, well, 0.05 divided by 1 is 0.05, right? When you add that, you get 1.05 on the bottom, and then 1 times 5 makes that exponent of 5. Then take the 50,000, and let's see what 1.05 to the 5th power equals. Ooh, that's giving me a lot of numbers. 1.27628. Quite a bit more, but that's all right. Now, to get the final answer, we divide that. So 50,000 divided by looks like I'm getting $39,176. And rounding to the nearest tenth, I got a 0.308. That's going to give me what, a 0.31. So check this out. If you use this bank with an interest rate of 5% annual compounding, in order to have $50,000 in 5 years, you got to start with $39,176.31. So I guess in 5 years, you made what, about $11,000 or so? Okay. All right, I got time for one more of those, okay? Same type problem, though, because those are funner parts, right? Anyone got questions online?
No.
All right, so let's see. If y'all are in college, I'm going to do this. How much must be deposited today into an account in order to have. So we want $120,000 for my kids' college fund in 16 years. The account has quarterly compounding. APR is 7.51%. How much must I deposit today in order to have $120,000 in 16 years? No, we're using the same formula. We're looking for the starting amount, which is B. We know that A, which is the final amount, that's going to be what, 120,000? So we're going to put 120,000 on the top. Divide that by 1 plus APR. Right, y'all, APR is 7.51%. I need to turn that into a decimal.
Decimal.
So that's going to be a long number, right? So y'all have to add 1 0 to that. So what do we get? 0.075. There you go. And then what's my N? How many compounds is in a year or quarter?
4.
So there's 4. Those in parentheses. And then out here is 4 times the number of years, which was 16.
16.
Yep, there you go. And I'll tell you the truth, most of the work's on the bottom of this until you get to that very last step. Dividing the top by the bottom is the very last step to do, okay? So here we go. We got a 120,000. So I'm just going to figure out what this bottom is going to give me. So I got parentheses, 1 plus 0.0751 divided by 4. I'm going to close parentheses and then raise that to the exponent of a 4 times 16. All right, y'all, when I did that, I ended up with 3.288. I'll just go out so many decimal places.
You put the 1 plus.
I did 1 plus 0.075 divided by 4. And then I took that answer and raised it to my exponent.
Well, I just figured out that.
Oh, you know the only thing that got you on yours? You've got to divide that by 4. You have 1 plus 0.0751 divided by 4. And then raise that.
All to the 16 because we can't put all that in there, right?
Right.
Okay.
So now, well, you see right here, where you got the 0.0751, you did divide it by 4.
Okay, so I don't put the 4 times 16, I just put the 4. Oh, I see what you're saying. I didn't do that one. Okay.
You skipped it. You sort of skipped it.
Okay.
All right, y'all, here we go. Let's take that 120,000 and divide all this stuff on the bottom.
Is that gonna be 36489.7?
Oh, let me get it for y'all. Let's see, y'all. Okay, here's what I got. So this is what y'all were saying. I couldn't hear. 36,489. And in rounding 2 decimal places, it looks like I had a 0.79 something. I'm gonna round that to a 0.80. Oh, no, my bad. I'm gonna leave that at 0.79. Because after mine, I had a 1.
Okay. Yeah.
Oh, you know what? You just got 1 0.
Lord, why I keep getting
1 2 0 0
I
0
think
0.
I think it's probably messing with
Uh-huh.
my eyes.
And then you did by 3.2886. So now there we go.
I'm doing it right, but I'm just missing.
489 point. And then yeah, just a little bit of rounding and stuff. So what you gotta watch out for on these ones is rounding errors. So what I would do on your calculator to get these exactly the right answer, I would take the original problem I got, the very top one, the 120,000. I'm going to do 120,000 divided by, add extra parentheses to the bottom.
Okay.
So add parentheses, and then do the parentheses that they got. 1 plus 0.0751 divided by 4, those parentheses. Do your exponent, which was what, 4 times 16? Arrow over, and then close those parentheses. Because now what you're putting the whole thing in, but you count the calculator at the 120,000. Everything else is on the bottom.
Mama, her thing disease.
Oh, okay.
Tell her
Round off
my
that,
closet
instead
is
of 9,
empty now.
now 1 instead of 7.
That's
Those
right.
calculators,
I called
those
her this morning.
calculators
She
y'all
said
got,
she
it's
had
better
a
to
rough
put
night.
everything in there at one time.
And I said, you did. She
doing it
was
like
like,
that.
yeah.
Right.
I
So if
had
you're
a
doing it
rough
on a
night. I
book,
was
you
at-
put extra parentheses around the bottom, okay? Because what's happening, we get round off error. And since we're looking at the nearest 2 decimal places, sometimes it takes a lot more up here to make it more accurate. So I try not to really round in my calculator until I get to that very last step. Because sometimes if you lose too many digits inside there, it messes up the. They won't alter it much, but it might turn the 79 into something else. And guess what? The little math lab, it's not very flexible. It wants them like exactly the same. You know, it don't give you no leeway to play with on those. So y'all, that's the world of simple interest and compound interest. So I'm gonna quit sharing that screen. And let me catch a few names real quick. So I got Rodney, Tony, Carla. Let's see, I got Jackson on here. Jackson. Oh, that seems like everybody. So what I'm going to do, I sent y'all a email that had a file for y'all to use for my project we're going to do. I can't pull it up in the lab today, so I'm going to alter that by just about a few days. Hopefully Tuesday I can get in the lab and show y'all what to do on that. It's not real hard. You just got to be able to pull up the Excel. And then it has places where you are going to put in your income and your bills and stuff. And it's going to figure out like a little budget for y'all. I sent y'all a file for that, but I'm going to wait till Tuesday to do that because our labs are not doing right for me today. So, main thing y'all want to do this week is what, 4A and 4B in the homework, okay?
Okay.
And you was pretty good on your 4B, pretty good. Now you're going to have stuff that shows due. Anything that shows due at the moment, don't worry about it. I got to adjust those due dates somehow. But anything I've got on there for y'all other than the test will let you work past the due dates. Okay?
Okay.
We're working on, you said 4B and 4D?
No, not D yet. D will be what I do Tuesday. Okay, so y'all just need to do 4A and 4B this week. Bravo. Alpha Bravo. How about that?
Okay.
All right, so, okay, on line when I was doing my lecture, was I understandable?
Yes, you were.
Okay, so was it better than it was Tuesday?
Yeah.
Okay, so I'm gonna keep using these headphones then. All right, y'all, if y'all have nothing else, I'm gonna close this out and I'll send this video out later.
Okay, thank you.
All right, y'all have a good weekend.
You too.